Hello everyone, this is Arun here. So we'll be seeing the contents of week 9 in this live session, which is the topic related to the hydrologic analysis. And in this week we'll be seeing how to derive the direct runoff hydrograph for a complex storm. So you'll be given a unit hydrograph coordinates and we'll be given some rainfall values which occurs consecutively in each hour. And for this kind of storm event, we need to derive the direct runoff hydrograph. And in the second question, we'll be seeing how to get the unit hydrograph for a d-hour duration using the S-curve method. And in third question, the S-curve will be given in the form of an equation instead of a table. And we'll see how to get the different unit hydrograph parameters like estimation of the peak flood discharge for some duration by using this equation. And in the last part, we'll be seeing the synthetic unit hydrograph, which in that we'll be seeing Snyder's unit hydrograph method. So we'll be seeing the problems related to these four topics. So the first question is the estimation of or the derivation of the direct runoff hydrograph for a complex storm. So in this question, 1 hour unit hydrograph for a catchment and the average aerial rainfall for a particular storm event in the watershed is given. Now we need to determine what is the direct runoff hydrograph, assuming that the watershed has a phi index of 0.7 centimeters per hour. And in the second question, we need to assume that a rainfall excess of 5 centimeters is given, and first we need to find the phi index for this particular condition. Then using this phi index, again we need to derive the direct runoff hydrograph for the same kind of rainfall. So if you see the table, we have the duration, which is ranges from 0 to 6 hours, and in each 1 hour duration we have different rainfall events that happen, and the 1 hour unit hydrograph coordinates are given for this particular catchment. Now we'll see how to solve this kind of question. So from the infiltration module, we know that the runoff or the rainfall excess is generated only when the rainfall intensity is greater than the infiltration rate. So we need to remember this first. So from this we will be deriving what is the excess rainfall. So once we get the excess rainfall for each duration, we can then multiply the excess rainfall with the unit hydrograph coordinate to get the corresponding direct runoff hydrograph coordinate. So I'm going to write down the table that is given in the question. So this is the rainfall that happens in the catchment, and the unit hydrograph coordinates are also given in the question. Now we have the phi index that is given in the question. So phi index is given as 0.7 centimeter per hour, and here it is each duration interval is 1 hour only. So I'm going to write phi index in terms of centimeter. So phi index is 0.7 centimeter per hour. So 0.7 into 1, that is again 0.7. So for all the duration it will be uniformly 0.7. Now we need to compare the rainfall and the phi index. So excess rainfall occurs when rainfall is greater than the phi index. So here in 0th hour, 5th hour and 6th hour there is no rainfall. So we won't have any rainfall excess. So next column will be the excess rainfall. I am terming it as ER, that is in centimeters. So that is rainfall minus phi index. So here it is 0 itself because we don't have any excess rainfall. For rest of the rows we have the excess rainfall. So that will be 0.55, 1.8, this is 3.3, this is 0.6. So I am taking the difference between these two. So once you get the excess rainfall, we need to multiply it with the unit hydrograph coordinate. So let the excess rainfall be P1, P2, so on up to P7. So here at last we will be having the 7th hour. We'll come to that. So we'll have up to P7. So we'll have P1, P2, so on up to P7. Now we need to multiply P1 with the unit hydrograph coordinate U1, U2, U3, so on. But here we need to be careful because we have a different rainfall events that starts at a different time interval. So let's see what is the difficulty, what is the thing which you need to be very careful in this question is. So P1 U1, which means I am going to multiply the rainfall excess corresponding to the 0th hour with the unit hydrograph coordinate of the 0th hour. But rainfall is 0 and the excess rainfall is also 0 in this case. So the entire row will be 0. So here P1 corresponds to 0 centimeter of rainfall excess, P2 corresponds to 0.55 centimeter of rainfall excess, so on up to P7 will be again 0 centimeter of rainfall excess. Then similarly we have to do for P2. P2 U1. So that means I am going to multiply 0.55 with all the unit hydrograph coordinate. But the thing to note here is we won't multiply it for the first row because the rainfall starts only at the first hour. So we'll be multiplying 0.55 into 0.27. So that is where the coordinate will start. So this the other rows will be blank. So if we multiply that, we will get the values as 0.1485, 1.595. So I'm marking it in green color so that we can refer it later. So I'm multiplying these two coordinates and then I'm giving it here. So next is 3.41, 2.3485, 5785, and this will be 0.70. So similarly we have to continue for P3 and U1. So P3 here is 1.8. So for the first two rows, that is 0th hour and the first hour, we don't have any rainfall, so we should not multiply for the first two. For the rest of the other rows, we have the rainfall happening, and because of this 2.5 centimeter of rainfall, we have a rainfall excess of 1.8 centimeters, and this 1.8 centimeters will generate the unit hydrograph coordinates. So here we are multiplying with the so this will be 5.22, 11.16, 7.686, 5.66, 2.5. So similarly we need to go for a P4 U1. So for the first three rows there will be nothing because the rainfall starts at third hour, and for the rest of the time step it will be we will have the unit hydrograph for 20.46, 14.091, 9.471, 4.62, Then we have the P5 U1. So first 4 rows will be blank. So rest of the 3 rows will have the values 2.562, 1.722, 0.84. Then P6 is 0 and P7 is also 0. P6 U1, P7 U1. That is the last 2 rows of rainfall. We don't have any values. Now to get the DRH, we will make the summation of all this ordinates which we found. So that will give the cumulative effect. So this will be in meter cube per second, and we can simply add. But if you see, the direct run of hydrograph starts at 0 and ends at 0. So we can add one more row here, 7th hour, which has a 0 rainfall, and unit hydrograph ordinate is 0. File index is 0.7, and this will be 0. Rest all will be 0. Just to make it come to the x-axis, nothing else. So now we add all the values. So that will be 0, 0.1485, 6.815, 25.03, so we have found the DRH ordinate for a complex storm given a phi index. Now for the part B of the question. So this is for part A. Given that excess rainfall is equal to 5 centimeters. Excess rainfall is given. Total excess rainfall, not for a particular duration. Now we need to find out what is the phi index for this much amount of excess rainfall. So for the first trial, so we don't have to make use of the trial. One of my previous videos I would have taught you how to find out the phi index without the trial and error method. So here we can come to the rainfall table. So here if you see, our total excess rainfall is 5 centimeters. Now if I add the first hour rainfall, that is 1.25, plus the second hour rainfall, that is 2.5, and the last hour rainfall, that is 1.3, we get the value as 5.05, which means that one block is excess, I would say. But let's say that if we do like this, we eliminate any one of the uh, three which we selected. So let's say that we eliminate the fourth block. So our rainfall will be now 1.25 plus 2.5, that equals 3.75. So the 5 index will be because of the rainfall blocks which is occurring due to the fourth, third hour and the fourth hour. So that is we have the period of rainfall excess as so we have the period of rainfall excess because of two blocks. So here we need to eliminate two blocks of rainfall. So let's say we are eliminating the first and the last one. So that is we eliminate the 1.25 centimeters, and we eliminate the last one is 1.3. So we are doing this just to find out the time of excess rainfall. So we are interested in finding out duration of rainfall excess. So total number of blocks is 6 blocks. Eliminate 2 blocks. So this is 6-hour duration, this is 4-hour duration. So the rainfall excess occurs for 4 hours. So if we calculate the 5 index now, we need to add all the rainfall. So this is P minus R divided by T. This is the formula. In P we need to make the summation of all the rainfall blocks. So first is 0, then we have 1.25, then we have 2.5, then we have 4 plus 1.3 plus 0 plus 0. So these are the rainfall that is given from the 0th hour to the 6th hour. Then minus your rainfall excess is 5 centimeters. Since we have eliminated the two blocks, we have to put the time of excess rainfall period as 4 hours, and this will give you 0.81 centimeter per hour. Now we can check this whether it is correct or not. So for check, P minus 5 into T should be equal to your runoff. So we can check that easily. Now we got the fine index. Now we need to proceed with the calculation of the direct runoff hydrograph. Similarly, in the previous part A, we have done the same thing. So this is time in hours, this is rainfall in centimeters, and here we have the unit hydrograph coordinate, that is meter cube per second per centimeter. This is 1 hour unit hydrograph. And now we have the fine index. So this fine index will be changing. That's the only difference. So rest of the procedure are similar to the previous part A. So in this way you can find out the DRH for a complex storm. Okay, let's move on to the next question. So next question is related to the S curve meter. So in this, the ordinates of a 2-hour unit hydrograph is given. Now we need to determine what is the 3-hour unit hydrograph by the S-curve method. So here we use the S-curve method to derive the unit hydrograph, which is not an integral multiple of the given unit hydrograph. That is, here we are given 2-hour unit hydrograph and 3 is not a multiple of 2. If it is a multiple of 2, we can use the method of superposition. We can just lag the given hydrograph by that many number of hours and we can find out the uh, unit hydrograph for the integral multiple, whichever is given. Say like 4-hour unit hydrograph or 6-hour unit hydrograph or 8-hour unit hydrograph, like that. But here we need to find out what is the 3-hour unit hydrograph. So in such situations, we'll be using the S-curve method. So let's see how to solve this problem. So I'll just write down the table. Here we'll be doing all the calculations in terms of tabular column. So in question, we have up to 11 hours of data. So rest 3 will come at the later stage. That is the part of the question. So first step is to do the S-curve addition. So I will term the S-curve addition as SCA, and we need to find out what is SA. That is the S-curve for the given 2-hour unit hydrograph. So for that, if you see the ordinates, it's not in terms of multiples of 2. So when you do the S-curve calculation, you need to be careful because we'll be taking 2 ordinates here to uh, do the S-curve addition. So the first 2 will come here. So this will be 0.18, 0 and 0.18 as it is. Now what we have to do is, we need to bring this 2 ordinates into the, so I'll mark the steps first. So this is the first step and this is the second step. So we need to bring both the ordinates to this place, to the third column. So that will become, so if I bring that, so this will be 0 and this will be 0.18. Now we need to add both and then display and then give it in the next column. So I'll write it properly so that you can easily refer later. So this is first step. 0 will come into this place and this will come here. So that is the second step. So here it will be 0, here it will be 0.18. Now we need to add second and third column and then put it in the fourth column. So that will be 2.5 and this will be 9.08. So again we need to add both and then leave it here. Next, again we'll bring these two coordinates together to the respective places and we'll be continuing. So that will be 2.5 and 2.08. Again we need to add this. So this will be 20 and this will be 34.78. So we'll keep continuing until the end. So I have done the calculations. You can try it. So until now what we have done is so if this is Q and this is time, we have a excess rainfall that is continuing for infinite time period. So each block is a 2 hour duration. So what we have done is, so this is the first unit hydrograph, then this is the second lagging, third, fourth, so on. We keep on doing the same thing and then we add it together. So that will give the equilibrium discharge. So that is what we have obtained as a 55.88. Now we are going to lag this S curve by 2 hours. So I am terming this as SA and the next one as SB. So we are going to lag the ordinates by 2 hours. So let's see what is meant by that lagging. SB. So I am going to lag by 2 hours, which means the first ordinate of SA will start at second hour. So since here we need to find out 3 hour unit hydrograph, we need to lag this SA by 3 hours. So your first ordinate will start at the third hour, and you need to write down the SA values one by one. 0.18, and then this is 2.5, 9.08. So next is 20. This is 34. So we have lagged it. Now we need to find out the difference between these two S curves. So that will be the offset. That is SA minus SB. So this will be 0, 0.18, and 2.5. So we are taking the difference between these two, and we are writing it here. Now we have found the offset, but we need to determine the 3-hour unit hydrograph ordinate. So 3-hour unit hydrograph ordinate is given by SA minus SB divided by T by D. That is the excess rainfall. So here T corresponds to 3 hours, which is the unit hydrograph that is required, and D corresponds to the given unit hydrograph, 3 by. So we'll divide each of the ordinate by this 3 by. So in this way we can find out the unit hydrograph for a different duration, which is not an integral multiple of the given unit hydrograph. Now let us see one more interesting question. That is the question number 3. Here, the S curve for the 2-hour storm is approximated as S of t is equal to 7t divided by 1 plus e power minus 0.75 into t minus 4.3 whole power 1.6. Here st is the S curve ordinate at time t. So from the S curve graph, we have that curve. They have found out the equation of that, and they have given it in the question. and this corresponds to a 2-hour storm. Using this equation, we need to determine what is the peak discharge if the rainfall excess during a 5-hour storm is 5 centimeter, and we need to assume the base flow of 20 cubics. So we'll see how to approach this kind of question. So in the question, the S-curve equation is given. So that is S of t is equal to 70 divided by 1 plus e to the power minus 0.5 t minus whole power 1.6. Now, to find peak of a 5-hour storm due to rainfall excess of 5 centimeters, we need to find a 5-hour unit hydrograph. So given is a S-curve for 2-hour storm, but for a 5-hour storm and a 5-hour rainfall excess, we need to know what is the peak of the 5-hour unit hydrograph. So that is the first task. So to derive, expression for a 5-hour unit hydrograph using the S-curve method. So this is the first task which will be done. So we know that if the S-curve is given, we can lag the S-curve, and then we can take the offset of it, and we can find out what is the unit hydrograph for a different duration. So given is a 2-hour unit hydrograph, and we need to find out the 5-hour unit hydrograph. So we are going to lag this particular S-curve by 5 hours. So we have the expression for ST. We are going to lag it by 5 hours. So which means S of t minus 5. So even in the equation, so that will be 70 divided by 1 plus e to the power of minus 0.75 t minus 4.3 minus 5 whole power 1.6. Wherever we have t, we have to substitute t minus 5. That's what we have done. So the lagged S curve ordinate will be 70 divided by 1 plus e to the power of minus 0.75 t minus 9.3 raised to the power 1.6. So this will be the lagged S curve. So once we know S of t and S of t minus 5, we can find out the unit hydrograph. That is, your DRH of 5-hour duration can be obtained by subtracting S of t minus 5 from S of t. So this is the offset we are talking about. We are just doing, this is similar to SA minus SB. So this is SB and this is SA. What we are going to perform is we are going to find out SA minus SB. That's what we are going to do. So the resultant will be a DRH of 5-hour duration, and after we get the DRH, we need to divide it by the excess rainfall. So that is T by D. So we'll see how to do that. So first we can write down the expression. So the excess rainfall will be T by D centimeters. That is, D is equal to 5R and D is equal to 2R. So the excess rainfall will be equal to 5 by 2, that is 2.5 centimeters. So to get the unit hydrograph, what we will do is unit hydrograph of 5-hour duration as a function of time is equal to S of t minus S of t minus 5 whole divided by the excess rainfall. So that will be UH of 5-hour as a function of time is equal to minus 28 divided by 1 plus e power minus 0.75 t minus 9.3 whole power 0.6. Now we have a function of a unit hydrograph in terms of time. Now in the question, we are asked to find out what is the peak discharge. So to find out the peak discharge, we can make use of the differentiation. So So for any function, we have the maxima when df of t by dt is equal to 0 and d square f of t by dt is less than 0. So this is the condition for maximum. So what we will do here is we will find out d by dt of unit hydrograph of 5 hour of time t and equate it to 0. So if we do that, we will get an expression like this: 33.6 e to the power minus 0.75 . So on solving this, we will get the time. So we need to make use of a trial and error method in the calculator. So we'll get the time as 7.6 hours. Now we need to check whether this this maximum or not. So we have to find out d square uh of 500 t divided by dt square evaluated at t is equal to 7.6 hours. So this is a little big expression. So we need to substitute t is equal to 7.2 in this, and then we need to check the value whether it is less than 0 or not. So this is equal to so which is less than 0. So now we can obtain the peak of the unit hydrograph. Unit hydrograph 5 hours, T is equal to 7.6, which is equal to so this will be equal to 22.15 meter cube per second per centimeter. Now we have to determine the flood hydrograph flood peak is equal to excess rainfall into unit hydrograph plus base flow. So excess rainfall is 5 centimeter and this we found as 22.15 and base flow is given in the question as 20 cubics, that will be equal to 130.75 meter cube per second. So this is how you solve when a S-curve equation is given instead of a table. Now we'll see the last question, which is related to the Snyder's synthetic unit hydrograph. A similar question has been solved in the lectures also. So here we have two catchments M and N, and the properties of the catchment is given. Length along the centroid, the length of the drainage path, area. Now we need to for a 6-hour unit hydrograph in the catchment 1, the peak discharge occurs at 37 hours from the start of the rainfall excess and the value is 200 cubics. Assuming that the catchments M and N are geomorphologically and meteorologically similar, determine the element of a 6-hour synthetic unit hydrograph for the catchment N by using the Snyder's method. So we'll see how to solve this question. So we have two watersheds. And some properties are given. So we have a 6-hour unit hydrograph. So the duration of the storm is 6 hours and basin lag is given for the watershed M, that is 37 hours. This is the parameter T and PR, and peak is given as 200 meter cube per second. Area of this catchment is 2718 kilometer square and length of the drainage path is 148 kilometer and length of the centroid is 76 kilometer. Length of the path near to the centroid. And the watershed N also has some properties. 1400 kilometer square of area, LS 106 kilometer, LC is 52 kilometer, and we need to derive the unit hydrograph for the duration of 6 hours in this catchment. So the first step is to check whether the derived unit hydrograph is a standard unit hydrograph or not. Check. So the definition of a standard unit hydrograph is here time to peak should be equal to 5.5 times of TR. So if we find out 5.5 into 6, that is equal to 33 hours, which is not equal to TNPR, which is 37 hours. So we need to define the basin lag first. So we use a modified formula, that is TP is equal to 22 by 21 TNPR minus TNR by 4, that is equal to 22 by 21 into 37 minus 6 by 4. Now we have TPS 37.19 hours. Once we get this, we can estimate the coefficients. Estimation of coefficients CP and CT. So we have the equation for CT as TP divided by 0.75 L into NC power 0.3. So if we substitute the values, 37.19 divided by 148 into 76 to the power 0.3, we have CT is equal to 3.0202. So this is the first parameter. Now we can estimate the second parameter CP. CP is equal to QNPR into TP divided by 2.78. That is nothing but Q divided by area of the watershed M into TP divided by 2.78. So we can find out the divided by area is 2718 into this we estimated. So we have CP is equal to 0.9843. So once we estimate the CP and CT, we can now move on to the watershed B. Okay, let's move on to the watershed B. First we need to define what is the basin lag for watershed B. That is given by TPR is equal to 0.75 CT into LD into LC to the power 0.3. So we derive the parameters from the watershed M, and then we are using it in the watershed N. So this is 0.75 into 3.0202 into 148 into, here we have 52 into 106 to the power 3. We have TPR is equal to 30.03 hours, and we are checking TR is equal to TPR 5.5 and T.03 divided by 5.5, that is equal to 5.459 hours. But we have the duration of the required unit hydrograph as 6 hours. That can be divided by TR dash is equal to 6 hours, but we have TR as 5.49 hours. So in order to adjust the basin lag, we are making use of this equation. TPR dash is equal to TPR minus TR minus TR dash divided by 4. So we are adjusting the TPR dash such that we don't have any effects on the rainfall duration. We don't have any effect on the peak because of this difference in the duration. TPR dash is equal to So for the rest of the calculation, we'll be using this modified lag for the watershed M. Once we got the basin lag, we can compute the QP 2.78 CP divided by TP. Here we are using the first lag which we got. Later we'll be adjusting with the ratio. Now we are going to adjust this QP with the ratio. QP into TPR which we got first divided by TPR dash, that is the adjusted one. So now we got the peak discharge per catchment area. Now we need to find out what is the time base. So time base is given by 5.56 divided by 2pr. Next we can find out what is the peak discharge. Peak discharge is equal to Qp into the catchment area, that is 0.09 into catchment area is 1400. We have the peak discharge as 126.98 meter cube per second. The last parameter is the width of Snyder SUH at 50% and 75% of QP. So width at 75% QP is given by 1.22 QPR power minus 1.08. That is equal to 16.298 hours. 2.14 QPR power minus 1.08. That is equal to 28.588 hours. Now we need to find time of rise or time to peak from the start of the rainfall excess. That is given by TR by 2 plus TPR. Next we need to determine, so we'll be distributing the width at 50% and 75% by a rule, that is 1/3 will be to the left of the peak and 2/3 will be to the right of the peak. So we are calculating the ordinate for that. So this will be 23.635 hours. Similarly, we have to calculate for the 2/3, on the right hand side of the peak. That will be T2 plus 2/3 of W50. First will be W75. That is 44.0303 hours. The next one will be TP plus 2/3 of W50, 52.223 hours. The last will be the base, where the hydrograph ends, that is Snyder. So if we quickly plot it, how will it look like? So first we have QP. That happens at 33.165 hours. Let's say that is somewhere here. Now we have width at 75% of the peak and width at 50% of the peak. And to the left we will have 1/3. Similarly, here also 1/3. To the right we will have 2/3. Similarly, we will have 2/3. and it starts at 0th ordinate and ends at 62nd. So this will be the time to base. So this will be capital T2. Now we can draw the unit hydrograph. So this is the width at 75, width at 50. And here we have the excess rainfall, and this duration is TR by 2, and the peak, this is PPR. So this is how you find out the Snyder's unit hydrograph parameters and the associated values. So that's it for today's session. Thank you.